A hypergraph is a pair of VE where V is a set of vertices and E is a family of sets of vertices. A hyperpath is a sequence of P equal to U0 E1 so on Vk minus 1 Ek Vk of distinct vertices and distinct edges such that vertices Vi minus 1 and Vi are elements of the edge Ei. I less than or equal to n less than equal to I less than equal to k. Two vertices U and V are connected in a hypergraph if the hypergraph is a UV hyperpath. A hypergraph is connected if every pair of vertices are connected. A bipartite graph is a graph G whose vertex can be partitioned into two subsets x and y so that each edge has one end in x and one end in y. Such a partition sy is called bipartition of the graph. A complete bipartition graph is a bipartition graph with bipartition xy in which each vertex of x is adjacent to each vertex of y if mod x equal to m and mod y equal to n, such that graph is denoted by AMN. An important characterization of bipartite graphs is in terms of odd cycles. Say a graph is bipartite if and only if it does not contain any odd cycle. A graph is called planar if it can be drawn in the plane without any two edges crossing. Notice that there are many different ways of drawing a planar graph. A drawing may be obtained by mapping a vertex to a point in an embedding of G. An embedding divides the plane into finite number of regions. The edges which bound a region define a face. The unbounded region is called an external or outside face. A face is called an odd face if it has odd number of edges. Similarly, a face with even number of edges is called an even face. The dual of a planar embedded T is a graph Gt equal to Vt Et such that Gt equal to V is a face of T and two vertices share an edge if their corresponding faces share an edge in T.